Assalamu alaikum. My name is Ismail.Riaz. Now I'm gonna make a video explaining how a computer works and what goes on inside a computer when we use it. So let's get into it. So what is a computer? A computer is an electronic information processor. It basically takes any input that we give it, stores the data from that input, and then processes it. Any input that we can give it, it can process it, it can store it, and then depending on what we ask it to do, it can process the data and then give us an output depending on what we ask. In a scenario, imagine a friend solving a math problem, and the letter she receives is the input that we give the computer. Her memory is where she stores the data, and then her brain processes the data, checks what formula to apply, whatever the math problem might be, and then gives us an output by writing it or telling us. Anything like that can be considered like how a computer processes the information we give it. It's much more complex, but this is like a simple way to describe it. Here are the core functions that happen in a computer. We have input, where devices like keyboard, mice, and sensors, these are like the hardwares that we use to input the devices. Keyboards can be used to input any information like words, numbers, anything we want. Mice can be used to click around the screen and give any input that we want to give, and sensors can be used to measure proximity of something or the temperature of something, anything, and then give this information to the computer. And then memory is where all the information will be stored. It's either in RAM or in hard drives and SSDs. RAMs are mostly short-term memory and more volatile, whereas hard drives and SSDs are long-term memory and more reliable. After we give it the information, it's gonna process with the CPU, which is a central processing unit. It acts as the brain and performs any and all calculations that are needed, and it performs them at lightning speed. And for us, it does it instantly, but it takes a few seconds only. And then it gives any output that we want. We can tell what we want from the output, such as we can input any numbers and then tell it to calculate something. The processing part, the CPU will perform any calculations needed on the input that we're giving, and then as a result give us any output on a monitor and display it. Or if we tell it to make a sound, we can use speakers, or if you want to print something, we can use printers. Any output. So the CPU is the computer's brain, as I said before too. It is the core of any computer, and it's responsible for nearly all the instructions that we give it. There's nothing that the CPU can't do. The CPU constantly fetches instructions from memory. Yeah, and then whatever instructions that it gets from the memory, it decodes them and then processes them and does all the operations that it has on them in a fraction of a minute, like very fast, and then gives us an output almost instantly. You can perform any operation such as arithmetic, logic. It also controls overflow and execution of programs. The modern CPUs are designed with multiple cores, which allows it to be extremely fast, even faster than it normally is. The newer the computer, the faster the computer is normally. So here let's talk about the data storage. All the data storage can happen on the RAM, which is a random access memory, or storage such as on a SSD or a hard drive or a hard disk, anything like that. RAM is mostly super fast memory. It's like it can only hold that memory until the computer shuts down, and it's really volatile in that sense that if your computer randomly turns off, the RAM will lose everything that it had at that moment. But it helps the computer act really fast when you're trying to perform an action or anything like that, because it takes whatever, like opening a browser might take a long time at first, but after you do it once and it's in the RAM, opening it again will be instant. It will take really less time because it's already in the RAM. And then the other storage is SSD or hard drives. These are more permanent sources of storing data. You can connect them to any computer and store any data on them, and it will remain there forever without the need of even the computer to stay on or off. Most of the time, the CPU accesses the RAM for quick memory, but if it can't, if the RAM is empty or it doesn't have the instructions on it, it accesses the SSD or hard drive, which is slower, but it makes the job done. So this is the software and hardware about a computer. A computer always has hardware and software. It cannot exist without the other. The hardware devices are anything such as a keyboard, a mouse, a monitor, the CPU button, or anything like that, that we can use to either input data or receive an output. Anything that we can touch, such as modules, motherboards, graphic cards, power supply, all of these things are hardware because we can actually touch them and hold them. Whereas software is what's inside the computer, which is the instructions and the programs that the computer has. This is like any app on the computer, or like the Windows, a Mac, Linux, or the processors, web browsers, like different thing for different scenarios. Like you can use Proteus, which is a software to simulate circuits. So you can first test it out in Proteus and then use it in the real world, any software like that. And this is one of the most powerful aspects, so you can use literally any software on any computer and it'll change the whole purpose of what the computer is doing, but the hardware will stay the same, so you don't need to get a new computer each time you have to perform a different task. This is the nervous system on the computer. Just like the nervous system, data inside the computer must move efficiently and reliably to ensure optimal performance. This comes with storage again, as RAM and SSD and hard drives are used along with CPUs to efficiently feed data and then process it and then give an output on whatever output device we have. These are some real world examples of how a computer runs. First, there's the hard drive of the CPU, which is the power button. Any computer has them. You can press them, turn the computer on or turn the computer off, and this will essentially perform a check on the hard drive, and then the startup will start. And the CPU then accesses into the storage drive, and then feeds a lot of the core files into the RAM, because the RAM is much faster than the SSD. This is why when you start up a computer, it takes a while to start up, because nothing is in the RAM yet, and all of it is on an SSD or a hard drive, which are much slower to feed information. So this is mostly where the time goes when a computer is starting. This process prepares the computer for user interaction. Yeah, it takes a bit of time. And then once loaded, the operation takes control, managing all hardware resources and providing a platform for applications to run. This is after the computer already starts up. Now you can press anything, open any application, and it'll work. And then if you open an application, then first loads the code into RAM, which is why the first time you open an application when your computer turns on, it takes a while because the RAM is still empty and or doesn't have the instructions of that application coded into it. So it first takes the code and then the CPU processes it all and then gives you any data as an output, like whatever you needed from that application. The evolution of computers from room size to pocket size. Back in the early days, like 1940s and ahead of that even, the computers used to be really big. Like this is the entire room size. I think there used to be huge servers for even the simplest tasks, often occupying entire rooms and costing millions of dollars. And it was only given to like huge governments or like complex calculations, not really for everyone. But nowadays, everyone has a small computer with them in the form of a mobile phone. Like it has a computer in it, or a smartwatch. It has a computer in it, or like any laptop, or even nowadays the fans and heaters and fridges have computers in them with sensors that if something gets too cold or too hot, the fan turns on or off, stuff like that. Fast forward to today, and billions of computers are seamlessly integrated into our daily lives. Computers are used everywhere nowadays, and everyone has access to it, unlike the early days. Relentless advances in CPU design, memory technology, and miniaturizing techniques, making computers power accessible and ubiquitous. So this is why understanding computers is also really important, and why I'm making this slideshow. Because nowadays everything we need to do is online most of the time. If you need to do any shopping, if you need to do banking, if you need to talk to anyone, if you need to consult anyone, you can do it on a computer. And if you try to use a computer without understanding it, it might be really difficult. It might lead to problems. So this is why knowing how computers work empowers you to use them more efficiently, which is what we really need to do nowadays. And you will dabble in programming. Programming is also essential. Computers are ubiquitous. Understanding their fundamental principles helps you navigate the increasingly digital world with confidence and critical thinking. As it says here, the world is slowly, or quite fast actually, going into digital territory. Everything is online nowadays, so it's really important we need to learn how to use a computer and learn how to efficiently apply all the things we learned here today on a computer. Journey inside a computer reveals the incredible ingenuity and technology that powers modern life, fostering a deeper appreciation of the tools we use. All the CPU, the memory, the RAM, everything that we just learned is really insane that it happens in a really small computer, like your mobile phone or something every day, and it's seamless. It happens really fast and everything. So yeah, that was my slide, and this was a video talking about how to use a computer and how to understand a computer. I hope it cleared up some things. Goodbye. Just before the video ends, I also just wanted to show how the hardware of the computers look like, such as the case, the power supply. This is the motherboard that is inside the case, connected to the power supply, the CPU, the RAM. The CPU is most of the time really small. The hard drive for storage, and the graphics card that handles most of the display of the computer, processes most of the display. And you can categorize them into the more simple use cases and the complex, where this provides power. This is for to hold everything inside the computer, such as the graphics card, motherboard, RAM, CPU, and hard drive. And the motherboard is just where we connect everything such as the graphics hardware and CPU, everything is connected inside the motherboard. So yeah, just wanted to describe this